Alright, we're going to start using our lovely trig identities again. So this is using substitution in trig equations. Alright, we want to find all the measures of x to the nearest degree. Woo, we like it when it's to the nearest degree. In an interval from 0 to 360. And notice here it says I want to include 360. You've got to read that. Sometimes they ask you to include 360, sometimes they don't. So I look here and first thing I see is my lovely sine of a double angle. Well, I need to solve that. I'm going to make that substitution. The 3 can stay the same, but the sine of a double angle turns into 2 sine of x cosine of x. Now tangent I'm going to substitute for also. I'm going to make that sine x over cosine x. And why am I substituting? Well, because this sine of a double angle turned into sine and cosine. So wouldn't I want tangent to turn into sine and cosine? I'm going to do a little algebra 1 right now. I'm going to multiply both sides by the cosine of x so I can get rid of a denominator and be left with one simple equation. 6 sine x cosine squared x equals, and over here is the whole reason we multiply by cosine x, so we get rid of denominators. What do I do now? Oh, I see that squared there. When I see a squared, I have to factor. That's my rule. But before I can factor, I have to set equal to 0. So I'll bring that x, sine of x over. And now I can factor. First step in factoring, greatest common factor. Yeah, I got a sine of x. That's my greatest common factor. So I'll pull my sine x out. I'll be left with a 6 cosine squared x minus 1. Ah, now I have my lovely table. I have my two factors. Right here, this is asking me to figure out where does my sine wave hit 0. In this one I've got a little more work to do. 6 cosine squared x minus 1 equals 0. 6 cosine squared x equals 1. Cosine squared x equals 1/6. And now I have to get rid of a squared, or a square root to get rid of a squared. But remember, when I take a square root, I have the positive answer and I have the negative answer. Alright, so finally I can start figuring out what my angles actually are. So I'm going to have to pull out my calculator. First one I'm going to work with is that one. That is asking me, where does the sine wave hit 0? Here's my sine wave. Here's 0. Graph it. And I see that my sine wave hits 0 in 3 spots. 1, 2, 3. I could do intersection, but they're pretty easy to pick out. Those answers are 0, 180, and 360. Okay, so let's come back. Now let's put my cosine wave in. Where does my cosine wave hit 1 divided by radical 6? There's my cosine wave. There is 1 divided by radical 6. It hits twice, so now I just have to use my intersection to figure that out. Where's my cursor? There it is. Let's shoot over, and let's get the reference angle first. 1, 2, 3. My reference angle is 66. So I'm going to have 66. Now I can figure out here that if this distance is 66, then this distance is 66. So 360 minus 66 is 294. If you don't like working with your reference angles, then feel free to do intersection. Fly it over. It's flying, it's flying. Hit 3 times. 1, 2, 3. And there it is, 294. We've still got this one to do. I'll come over to y equals. I'm going to insert a negative sign there. And there's my cosine wave. There's my negative. And again, I can do my calculate. I'm just going to jump over to the first one it sees, and it jumped over to the last angle, so that's 246. So now I have to come back over here, do it again, and should have found my reference angle first, would have made it easier. But 1, 2, 3, and my other angle is 114. So this had 1, 2, 3, 4, 5, 6, 7 answers to it. Which is kind of cool, because if I put the original problem in, if I set the original problem equal to 0, if I go in here and I type in this, was where it was set equal to 0, so if I get 6 sine x cosine x squared minus sine x, and I graph it, I may have to adjust my window, so it may take me a second here. If I graph it, I'm going to get a really wild looking graph. But as you can see, if I take a screenshot of this, as you can see, this graph crosses 1, 2, 3, 4, 5, 6, 7 times. That's why I got 7. All right, to try one more. Notice when we read the directions that we've got a little different here. We've got the word exact, which means there is no rounding involved. And we have radians, 0 to 2 pi. All right, so let's go to it. When I look at this, we have a 3, we have a sine, and we have a cosine. That's not good. It either has to be all cosine or all sine. So once again, I look on my trig identity sheet, and I realize that I do have a substitution. I can know that cosine squared x is 1 minus sine squared x. And we get that from the manipulation of cosine squared plus sine squared x equals 1. That's the identity. And then I know that if I take the sine squared x, the sine squared, I can move it to the other side. And that's where I get cosine squared x equals 1 minus sine squared x. So I'm going to make that substitution. 3 minus 3 sine x minus 2 parentheses 1 minus sine squared x. It's me 0. Basic algebra now. Clean it up. 3 minus 3 sine x minus 2, careful, plus 2 sine squared x equals 0. I see a squared. That means I'm going to have to factor. So I'm going to get it in order. Lead with your highest exponent, 2 sine squared, minus 3 sine x. 3 minus 2 leaves me with a plus 1 equals 0. Well, I like this one. This one can factor. It can go to 2 sine x minus 1 and sine x minus 1. There's my little factor. Remember, it's always set equal to 0. So where does 2 sine x minus 1 equal 0? All right, well, let me clean this up so I get a sine wave isolated. Where does the sine wave hit 1/2? All right, and over here, where does the sine wave minus 1 equal 0? Okay, where does the sine wave hit 1? Let's do one at a time. Let's do this one. I'll bring out my calculator. Y1 is going to be my sine wave, and Y2 is going to be 1/2. I'm going to graph it. There's my sine wave. There's 1/2. All right, so let's calculate my intersection. I'm going to go get my reference angle first. My reference angle is going to be the first time the two waves hit. And it's 30. Now, I know my next one, and again, I'm going to take a screenshot here. See, I know that this distance was 30. From 0 to there was 30. So this is 180 right here. So this distance is also 30. So 180 minus 30 gets me my other angle of 150. Or, once again, you could have just done second function intersection. Now 30 and 150 are not my answers because we come back up here and we realize that it has to be in radian, and an exact radian. So I'm just going to convert 30 times pi over 180 gives me an answer of pi over 6, and 150 times pi over 180 gives me an answer of, let's see, 5 goes in there 3 times, I'm sorry, 3 goes in there 5 times, 3 goes in there 6, so that would be 5 pi over 6. All right, let's come to the other side. Where does my sine wave hit 1? Here's my sine wave. And it only hits 1 once. Right here at 90. Convert that to radians. And there are my